Ukraine. We have oil, iron, gas, lithium, graphite, uranium, silver, gold, and many other minerals. 5% of world's mineral resources are in Ukraine. Among all these treasures, there is a special one: titanium ores, the feedstock for the metal of the future. How to mine ilmenite in Ukraine? How much of it is here? And what unique discovery did Ukrainian scientists from Velta made? A real world-class technological sensation. See next in our film. Your tablet, laptop, lamp in the room, mobile phone, different utensils, and many other things. Today, all of these are usually made of stainless steel or aluminum. But imagine that everything you touch countless times a day will be made of something else, a much more health-friendly, ultra-lightweight, durable metal, titanium. This sounds like science fiction.
We can make such a big step in the future. Because titanium can deliver strength, corrosion and impact resistance, decorative effect, because it looks gorgeous along with weight reduction. It will make products almost twice lighter than stainless steel.
All of this sounds unbelievable today, because titanium, the metal of the future, or the space metal, is extremely expensive. How to make titanium uncostly? A real scientific and technological revolution is underway in Dnipro.
Look, for example, in late 2018 we received this item. It was already the final metal product made from our own feedstock. The titanium content is not very high here, but it was in the end of 2018. And this is mid-2019. Here we have over 99%. This is Velta's first pilot product made from our own feedstock, all the way to the final product.
Businessman Andriy Brodsky holds a degree in mining. For almost 10 years he has been processing and selling ilmenite, titanium feedstock. Concentrated ilmenite, processed by Mr. Brodsky's facility, is high in titanium, but it is still just a feedstock. It still has a long and very expensive way to go to become a metal. Shortening the process and making it cheaper, this was the super objective the businessman set for himself and the scientists several years ago.
The idea was mine. I wanted to assemble a team and do something that nobody in the world has done so far. I wanted to create a titanium product that everyone will use. We are preparing a technology that will revolutionize the global consumption of metal.
Here we have almost 10 million tons of ilmenite ore under our feet. This is a unique Birzolivsky deposit. This is where a long way to obtaining titanium begins. Ukrainian Titanium Valley in Kirovograd region, Birzolivsky deposit. In total, here they mine more than 2 million cubic meters of ore per year at this open-pit mine. These resources, confirmed by international standards, are enough for several decades. It's just a titanic work, and it goes like this every day, 24/7, 365 days a year. Velta's mining and processing complex is the first such facility in Ukraine, built from scratch in all the years of country's independence. This factory produces up to 300,000 tons of concentrated ilmenite per year, which is about 5,000 railway wagons. Velta already holds 2% of the global market share for titanium feedstock. Another 120 tons per year will be mined at Likarivske deposit, which is currently under development, just 7 kilometers away from Birzulivske. Velta says the industrial-scale production was launched here according to the advanced global technologies. They are especially proud to comply with all environmental norms. You can see right away that a lot of money and heart was invested here. Perhaps that is why even a large-scale fire could not stop its operation. Back then, the fire destroyed 2/3 of production capacities. It was a devastating strike. But Velta, like Phoenix, was reborn from ashes and continued its way into the future. The one and only commercially successful process for the production of metal titanium still remains the so-called Kroll process. A great number of labor-intensive production stages and incredible energy consumption make titanium 10 or even 15 times more expensive than aluminum. And it was final skyrocketing price of titanium that stopped the spread of its application through the globe. Scientists from around the world have been unsuccessfully trying to solve this task for decades, to invent a new, greener, and more technological method of producing pure titanium. The ore needs to be cleaned, purified from everything unuseful. How to do it? Andriy Hunchar is a chemist. In 2017, he headed Velta RD Titan, a research and development center created by Brodsky specifically to make titanium a mass product.
We are going to make an incredibly high-quality product, which is really much better than the products of our potential competitors.
So what did they invent? This research center just grinds ilmenite mined at the factory. Instead of melting it in furnaces with coal. Chlorination, still used in the whole world, is not needed anymore. Now everything is much simpler and cheaper. After grinding, we add a secret for now: liquid, dissolve it, precipitate it in powder form, and dry.
We obtain the pre-feedstock for titanium production at temperatures generally below 120 degrees Celsius. Our process is a low-temperature process.
Thanks to this fundamentally new method, Velta obtains the titanium dioxide you've already heard about, TiO2. Here, they call it I-synretyl. They use the powder to make tubular feedstock elements. Next, they will be baked. And while the metal is being cooked, the inventor leads us back to the laboratory to demonstrate something equally important.
The main goal of our technology is the production of titanium dioxide, or I-synretyl, a raw material for further processing into metal titanium. But our technology enables us to receive also byproducts that have a very high added value. These byproducts actually will cover the major costs of titanium production.
The powder for the production of metal titanium is an expensive feedstock by itself. I-synretyl, or titanium dioxide, is a basis for a lot of things.
For example, the iron oxide pigments, black, red, yellow, are used in coating industry, plastics production, construction mixes, paving slabs. The global market for iron-based pigments is about 1.5 million tons per year, and all the iron included in ilmenite is used for such pigments production.
In addition, Velta team works on other byproducts, mineral fertilizers, various types of raw materials for the paper, coating, plastics, and metallurgical industries.
It was almost like an ideology from the very beginning to create the most efficient, cheapest technology at every stage of processing. We were aware that we had to work on making many other related products, the byproducts of ilmenite. Not only the titanium-containing component that we would turn into metal, but also something for later sale, a product with high added value. This was an idea of how to make the whole process cheaper.
He also says that neither the lab nor the factory have any waste. Even the sewage waters do not enter the soil. After purification, they re-enter production cycle.
From an environmental point of view, we have no solid or liquid waste, and even recycled carbon dioxide in our process, because we partially need it in our process as well.
Meanwhile, the titanium in the furnace is already cooked, without any noise and dust.
Here's the result of elements reduction to metal titanium.
Pure titanium.
Nobody in our field did anything like this for the past 60 years. They tried, but did not succeed.
It may seem that it is very easy to get such a result. On the other hand, indeed, Velta's new technology significantly reduces the time and makes the well-known path less expensive. But it was far from easy.
Many other research groups in 60 years haven't developed the full technology, although I will emphasize it again. Many of them have been working on it, and some even for 2 decades.
However, the inventors did not stop here. They turned titanium tubes into powder. They produce not one, but several fractions that differ in size, depending on the requirements of various industries.
Next, we use this powder for different techniques, such as 3D printing. You can make any details with various level of complexity.
This is the future which starts today. Technologies that use powder titanium, obtained 10 times cheaper than before, can significantly expand its application, believes Andriy Brodsky.
This was the way that aluminum manufacturers made 100 years ago. A bit later, manufacturers of stainless steel followed. Thanks to technological innovations, they made their product cheaper and earned the mass market. The same will happen to titanium. This will definitely come true in the coming years.
According to his plan, this durable, lightweight, and beautiful metal, which is also safe for human health, should finally stop being a space or elite one and become available to everyone.
I don't want to work in the defense sector. I don't want to work in the high-tech sector that consumes titanium. What I want is to work in the household consumption of titanium goods. I want every person to buy titanium products with the same ease as stainless steel or aluminum.
For example, tourists no longer need to be persuaded about the benefits of titanium. Lightweight and durable equipment has long proven itself. Doctors and patients who need titanium plates and implants also understand this. The next ones, according to Andriy Brodsky, are all housekeepers. They should wait for the titanium cookware and something more.
I want the cases of mobile phones and laptops to be made of titanium. I'm not interested in the current numbers of metal titanium production and its current market. I am interested in the market that can be created with the help of mass products and cost reduction of the final goods. I've been heading for it for many years.
Thanks to the revolutionary inventions of Velta's R&D Center, this goal is almost reached. The scientists produce titanium not in grams under the microscope, but in thousands of kilograms. This is the height of the scaling, and this is the breakthrough. Here is titanium produced through a new revolutionary process. 2 years of hard work, investments, brilliant solutions of unique scientists. And here is the result that will change the future. This story is perhaps the best example of how people make minerals really useful.